Hello and welcome to this revision session, which is on the mechanics topic for AQA A-level physics. So in today's revision session we're going to try and look at how you can answer examination questions for the A-level physics topic mechanics. So into this revision session, if we're being successful, we'll be able to answer A-level physics examination style questions, assess your understanding on A-level physics and understand what topics you need to improve upon for your A-level physics examinations. So how would you carry out this particular revision session? So when completing the work in your revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than that on the right hand side. Now in the left hand side section, write down your working out or answers to the questions in the revision session. Now when you're doing this, try to write in full sentences and show your full working out. Whilst on the right hand side, write down any pieces of information which you find useful or any hints and tips on answering questions from this revision session. At the end of this revision session, write up these notes into a revision sheet for you to use independently. So what tips would I have for you to revise A-level physics? So the first step I would suggest that you do when you're revising A-level physics is to learn the key facts. So use your revision guides, your class books, your prep notes, the textbook to learn the key ideas of the course. And to do this, you may wish to make mind maps or write out the notes yourself. The second step is to then test yourself. So use things such as Kerboodie, Seneca and Knowledge Checker to quickly test your own knowledge, and you may wish to do this from cue cards. Then the third step is to practice examination style questions. So use exam prep books, homework books, supervised study books, additional workbooks to help answer exam questions and mark your own work, and you may wish to download your own exam papers to do this. So you should be, if you're independently revising your A-level physics, is learning the key facts, testing yourself and then practicing the exam style questions. So let's start off with a few multiple choice questions in mechanics. So a conveyor belt raises 20 boxes, each of mass 60 kilograms, through a vertical height of 12 meters every 30 seconds. The conveyor belt operates at a steady speed. What is the useful output of the conveyor belt? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer for this one is B, because we know power is work done over time. Now work done is the force times by the displacement in the direction of the force. So you can say power is force times by distance over time. Now the first thing you've got to note in this question is you're given the mass in kilograms. So because it's moving a vertical height, therefore the force is going to be the weight of the object. So you would do 60 times by 9.81. Now also note in this calculation we have times by 20 because the 20 boxes being raised, each with a mass of 60 kilograms, and then obviously we times it by 12 because that is the vertical displacement, then dividing it by 30 because that's how long it took. So therefore we've worked out our useful power out to be 4.7 kilowatts. Let's have a look at the next question. A lamp has a useful output power of 8 watts and an efficiency of 12%. What is the input power to the lamp? So pause the video now, then unpause the video when you want to go through your answer. Right, for this one the answer is C, because we know our equation for efficiency. Efficiency is useful power out or energy out divided by total power or energy in. So therefore we rearrange the question and we put total in to be the subject. So we say total in is useful out over efficiency, and we pop our numbers in. Now again, remember when we're using this equation it's important to convert your percentage back into a fraction or a number between 0 and 1. So 12% becomes 0.12. So the total in is 8 over 0.12, which is 67 watts. The answer is C. Let's have a look at the next question. What is the relationship between the momentum P of a ball falling freely from rest and time t? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this one our answer is C, because as we'll be aware, momentum is mass times by velocity. Now if you can't remember that, that equation is found in the back of the exam paper in the equation booklet. Now as the velocity increases, the momentum will increase for the same mass in direct proportion. Now as an object falls from rest, the velocity is directly proportional with the time taken to fall, because the longer it falls, the faster its velocity, because we know it's accelerating due to gravity, which is a constant in this situation. So therefore P is going to be proportional to T. Let's have a look at our next question. Which of the following is a statement of Newton's third law of motion? So pause the video now, then unpause the video when you want to go through your answer. Right, so in this one, the answer is D. Now, it's very important that you've got to be aware of what Newton's third law of motion is. The first thing to note for the third law of motion is it's always between two objects interacting with each other. Now, when two objects interact, okay, that they'll exert, okay, an equal yet opposite force on each other. So when X interacts with Y, they'll exert a force on each other, okay, and that force will be of equal size, it will be in the opposite direction, and it will be the same type of force. Let's have a look at our next question. When a ball is thrown into the air at an angle to the vertical, which of the following is true? So pause your video now, then unpause the video when you want to go through your answer. Right, so what is our answer here? Well, the answer is B, because if you notice all the different options here, the force on the ball are balanced when it's at its highest point. That's not going to be the case in particular instant, because at that point it's going to start to instantaneously come back down and accelerate down. The ball's acceleration increases when it starts to descend. Okay, well, again, how do we know that is that going to be the case? Well, we don't, but what we do know is that the vertical velocity of the ball is zero at its highest point, because when it's at its highest point, it'll instantaneously stop moving and then come back down, so therefore our answer is B. Let's have a look now at a few longer questions on the mechanics topic. So, a spacecraft entering the atmosphere of Mars must decelerate to land undamaged on the surface. Figure 1 shows the spacecraft of total mass 610 kilograms entering the atmosphere at a speed of 5.5 kilometers per second. Calculate the kinetic energy of the spacecraft as it enters the atmosphere. Give your answer to the appropriate number of significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do we answer this question? Well, the first thing to note is we've got to know the equation for kinetic energy. So you know that kinetic energy is a half times by mass times by velocity squared. Now we know what our mass is, we're given it in the question. If we look, it's 610 kilograms. What's our velocity? Well, we know it's 5.5 kilometers per second. Now the trick here is, if we want to get our answer out in joules, we'll have to turn that into meters per second. So we'll be using 5,500 meters per second, because kilo means times 10 to the 3. We pop our numbers in, and you'll notice that in the numbers given in the exam question, we've got 2 sig figs for 5.5, and we've got either 2 or 3 sig figs for 610. So we go with the lowest possible value, which is 2. So we should give our answer to 2 significant figures, and we get 9.2 times 10 to the 9 joules. Right, let's have a look at our next question. So a parachute opens during the spacecraft's descent through the atmosphere. Figure 2 shows a parachute spacecraft system with the open parachute displacing the atmospheric gas. This causes the system to decelerate. Explain with reference to Newton's laws of motion why displacing the atmospheric gas causes a force on the system and why this force causes the system to decelerate. So pause the video now, then unpause the video when you want to go through your answer. Right, so it's very important that when we answer questions like this, we look at the labels given in the exam question and use this to help formulate our answer. Now, the first thing to note is that we've been given the direction of travel, and we've also been given the displacement of the gas. So let's link this into Newton's laws of motion. So why is there a force on the gas? Now, it's really important that you should really either give your understanding of Newton's laws in either momentum or resultant forces. So the first thing to note is that from Newton's second law, a change in momentum will produce a resultant force, or vice versa. So we know that the gas's momentum is changing. We know that because it's being displaced, so therefore this requires a force due to Newton's second law. Or you could say because the gas is being accelerated, that's also producing a resultant force. Now, the gas exerts a force on the parachute. Okay, so therefore we've now got two objects here. We've got the gas, we've got the parachute. So via Newton's third law, okay, the parachute will exert a force on the gas because the gas is exerting a force on the parachute of equal size, of the same type, but in the opposite direction. Now, what the next thing is, why will the system decelerate? Well, we know that things will accelerate or decelerate with a change in momentum or a resultant force. So you know it's decelerating because the resistive force is greater than the force causing it to come to the ground, which is the weight. So there's the resultant force in the opposite direction to the motion. Now, Newton's first and second law state that acceleration is always in the same direction of the resultant force, so therefore it will slow down. Let's have a look at our next question. As the parachute and spacecraft system decelerates, it falls through a vertical distance of 49 meters and loses 2.2 times 10 to the 5 joules of kinetic energy. During this time, 3.3 times 10 to the 5 joules of energy is transferred from the system to the atmosphere. The total mass of the system is 610 kilograms. Calculate the acceleration due to gravity as it falls through this distance. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do we answer this question? So the first thing you've got to be aware of is working out what our work done in our system is. So we start off with, well, 3.3 times 10 to the 5 joules. Okay, we finish with, we lose 2.2 times 10 to the 5. So therefore we've had a difference of 1.1 times 10 to the 5. So therefore we can say that this is going to be the work done due to the change, so due to the movement. So that's going to be the potential energy. So we can therefore say EP is equal to mgh, and we know that EP is going to be 1.1 times 10 to the 5 joules, because that's our potential energy, because it's changed there. So therefore if we say equals mgh, we can therefore make g the subject, pop our values in, and we get 3.7 meters per second as our answer. Let's have a look at our next question. Dust from the surface of Mars can enter the atmosphere. This increases the density of the atmosphere significantly. Deduce how an increase in dust content will affect the deceleration of the system. So pause the video now, then unpause the video when you want to go through your answer. Right, so how will you answer this question? So you've got to understand what density is. So density is how many particles there are in a certain volume. So if we've increased the density, that means that there are more particles in a certain volume. Now in our previous questions, we've understood that the parachute is displacing the gas, so it's moving the particles of the gas to a different place. So therefore, if the density has gone up, more mass is there to displace, so there's more particles to collide with the parachute, so therefore more of the gas or dust is displaced. So because we know that momentum is mass times by volume, there's a greater change in the momentum of the system because our mass is now bigger. So therefore we've got a greater change of momentum, or you could say greater work done, so therefore we need a greater resultant force on the system. Right, let's have a look at our next question. Figure 3 shows a golf ball at rest on a horizontal surface 1.3 meters from a hole. A golfer hits the ball so that it moves horizontally with an initial velocity of 1.8 meters per second. The ball experiences a constant deceleration of 1.2 meters per second squared as it travels to the hole. Calculate the velocity of the ball when it reaches the edge of the hole. So pause your video now, then unpause the video when you want to go through your answer. Right, so when you answer these types of questions, it's important to note, okay, it says it's a constant deceleration. So when you've got a constant deceleration or constant acceleration, you have to use the equations of motion, or SUVAT. So therefore what we can do is we can pop down what we know. So what do we know? We know that in this particular question that the acceleration A is going to be minus 1.2 because it's decelerating. We know that the initial velocity U is 1.8 meters per second. We know that the distance travelled S is 1.3, and we want to work out V, the final velocity. So we look at our equations of motion and realise we can use V squared equals U squared plus 2AS. Again, remember that A must be a minus value because it's decelerating. You pop your numbers in and you get 0.35 meters per second. Let's have a look at our next question. Later, the golf ball lands in the sandpit. The golfer hits the ball given it an initial velocity u at 35 degrees to the horizontal. The horizontal component of u is 8.8 meters per second. Show that the vertical component of u is approximately 6 meters per second. Then the ball traveling horizontally as it reaches x is shown. Assume that the weight is the only force acting on the ball when it's in the air. Calculate the time for the ball to travel to x. So pause your video now, then unpause your video when you want to go through your answer. Right, so in this first question, what can you do? Well, there's a number of ways in which you can work out the vertical component of a resultant force that you're given, or you can actually use it from the horizontal component that you were given. So what you could do is you could say that tan is equal to opposite over adjacent. Now in this triangle, we would know that opposite is going to be the vertical velocity, and then you could work it through that. Or how I would tend to do it is I would say, well, the horizontal component of u is u cos angle. angle, and that equals 8.8. So what I would then do is I could then use that to work out what u is. So I would say u is equal to 8.8 over cos 35. That gives me the value of u, and then I would say, well, the vertical component of u, uv, is equal to u sine 35. Now remember, if you're always giving the angle to the horizontal, in most cases, okay, the horizontal component is going to be the cos of the angle, and the vertical component is the sine of the angle. So you get your answer through to be 6.2 meters per second. Now in our second question, what do we know? Well, if the only force acting on the ball is weight, well, therefore it's acting as a projectile. So therefore what we can do is we can use our equations of motion. So once again, what do we know? Well, we know that when it reaches x, okay, that it's going to have a velocity of 0, so v is going to be equal to 0. We know u because we've got the horizontal and vertical components. Now again, I would suggest, okay, it says it's traveling horizontally as it reaches x. That indicates it's not traveling vertically. So we can say that in the vertical, the final velocity is equal to 0, and we've got the vertical component, which is u here, which we can say to be 6.2 meters per second. Okay, and at this point, we know that the acceleration is minus 9.81. We know this because it's going against gravity, which is going to be a 9.81. Okay, so what we can then do is we can use that to work out t, because you know v equals u plus at. We work it through to be 0.63 seconds. Right, let's have a look at the next question. The golfer returns the ball to its original position in the sandpit. He wants the ball to land at x, but this time with a smaller horizontal velocity than before. Sketch on this figure the possible trajectory for the ball and explain your reason for selecting this trajectory. So pause the video now, then unpause the video when you want to go through your answer. Right, so let's have a look at your answer. So what we need to do is as follows. So the first thing to consider is what's our trajectory of the ball going to be. Well, it's going to be a smooth curve because we know that it's curving upwards due to the effect of the actual motion like such, with the maximum turning point, and it starts and finishes at x, so it should be quite parabolic in shape as such, like that. Now why would you choose this particular trajectory? Well, if you increase the angle to the horizontal, the ball must go higher, so the ball must have a greater initial vertical velocity, or you could say that therefore it'll cover the horizontal distance over a longer time, so therefore it'll have a smaller horizontal velocity, so therefore that value of v will go down. Right, let's have a look at our next question. A student investigates moments by suspending a 100cm ruler from two force meters A and B. A and B are attached to the ruler 12 centimeters from each end. Their supports are adjusted to make A and B vertical and the ruler horizontal. So the ruler is uniform and weighs 1.12 newtons. Determine the reading on A. Then the student suggests that the force exerted on the ruler by A and B act as a couple. Suggest whether his suggestion is correct. Right, so pause the video now, then unpause the video when you want to go through your answer. Right, now the first thing you've got to remember is if you've got a suspended system and you're looking into moments and it's at equilibrium, there's two things you can remember. That the moments clockwise and anti-clockwise equal each other, but also the forces acting up and the forces acting down are equal to each other because it's in equilibrium. Now, what we know is that the force acting down is 1.12 newtons, so therefore the total force acting up must be 1.12 newtons, but there's two force meters, so it's divided between the two, so you get our answer to be 0.56 newtons. Now, it's suggesting that forces exerted by A and B act as a couple. Well, what is a couple? Well, a couple are two forces which act in the same plane, have the same size, but they act in opposite directions because it causes rotation. Now, if we look at this situation, it's not a couple because they are two equal forces, but they're both acting in the same direction, upwards. So it can't be a couple because they're not acting in opposite directions. Right, so the student hangs a mass of weight W on the ruler between A and B as shown in the figure. He adjusts the supports that A and B are again vertical and the ruler is horizontal. The mass hangs at a distance d from A, so the reading on A is 0.82 newtons and the reading on B is 0.62 newtons. Determine W, determine D. So pause the video now, then unpause the video when you want to go through your answer. Right, so when you're doing these types of questions, again, there's two things you've got to remember. The forces acting up is equal to the forces acting down. Now we know straight away, and also, sorry, the moments clockwise equal the moments anti-clockwise. So we can work out what W is quite quickly, because we know from the previous question that there's a weight acting downwards of 1.12 newtons, and we know there's a force of W acting down. We also know going upwards it's 0.82 newtons and 0.62 newtons. So you equate them. So you say the total upward force equals the total downward force. So therefore the force of W must equal to 0.32 newtons. We then use the principle of moments to work out our particular answer. Now, the easiest way to do this is take the moment about a point and consider, okay, where that point is. So you would then, and also remember when you're doing this, that you've also got to consider the actual moment due to the weight, which is found in the dead center of the ruler with a force of 1.12 newtons. So remember, to work out a moment, it's force times by distance. So you work out the clockwise moments and the anti-clockwise moments, and we say that a moment is force times by distance, and with that you can work out the distance of the object from A. Now, because we're working out the distance from A, it's probably best to take the moments from A as well. So you can do that and you get an answer to be 0.14 meters. Let's have a look at the next question. A river flows from west to east. The velocity of the current in the river varies from 0.2 meters per second near the banks to a maximum of 0.65 meters per second in the middle of the river. The current is always parallel to the bank. A girl swims from A and aims due north. Her speed relative to the water is a constant 1.1 meters per second, so that the magnitude of the girl's maximum resultant velocity is approximately 1.3 meters per second as she swims across the river. On different occasions, the girl swims in the direction with a speed of 0.90 meters per second relative to the water and with a variety of directions. State the magnitude and direction of the minimum possible resultant force that the girl can have. So let's have a look, okay, if you pause the video now, and then we'll have a go at answering that particular question. So the first thing to note is that when you're trying to work out the resultant velocity, okay, and it's got a horizontal and vertical component, well, you've got to use Pythagoras, and the resultant is going to be the resultant squared is equal to the horizontal squared plus the vertical squared. Now it's saying the maximum resultant velocity. Now you're given two values for the horizontal velocity here, but because you're working out the maximum resultant, you need to use the maximum horizontal. So it's say that the maximum horizontal squared is equal to 1.1 squared plus 0.65 squared, so you get an answer of 1.28 meters per second. Now in the next one, it says that she could swim in any direction with a speed of 0.90 meters per second. What's the minimum possible resultant force the girl can have? Well, if you have them in two opposing directions, they'll always add to give a value bigger. Okay, so the only time you're going to get the lowest possible value is when they're in the same plane and one's acting in the complete opposite direction to the other. So the minimum possible resultant force the girl can have is going to be the 0.90 minus 0.65, which is going to be the in the middle there in the opposite direction, so therefore she'd have to be swimming against that, which is due west, so therefore your answer is 0.25 meters per second. Let's have a look at the next question. Figure 2 shows a gymnast standing in equilibrium on a uniform beam, 3 meters from one end. The beam is 5 meters long and supports R and S are 0.50 meters from each end. The weight of the beam is 700 newtons and the gymnast has a weight of 470 newtons. Fs is the force exerted by S on the beam. By taking moments about X, calculate the magnitude of Fs. So calculate to pause the video now, and then we'll look at how you calculate your answer. Right, so how do you calculate this answer? So it's very important that you've got to take you've got to work out the moment of each force and then equate them where needed. Now the first thing to note is we're taking moments about X, so we don't need to consider the moment created by the reaction force of X, because the distance, which you remember moments are force times by distance, the distance is 0 from X, it's at X, so therefore any moment by the force produced by the support X is going to equal 0. So we can work out what our moment is from our gymnast, because it's going to be 470 times by 2.5. Now that's acting clockwise, that's acting clockwise. Now the other thing that's acting clockwise is the actual moment produced by the weight of the beam. Now we know the weight of the beam is 700 newtons, it tells you in the question, and we know that its distance from X is going to be 2 meters. We know that because the weight is assumed to act directly in the middle of the object. So 2.5 meters from the end, because it's total 5 meters, so therefore from X it's 2 meters away. Now in the other direction we've got Fs, which we can see is going to be, if you look on the values here, it's going to be 2 meters away itself, so therefore, sorry, 4 meters away by looking away. So what we can say is 2 times by 700 plus 2.5 times by 470 equals 4 times by Fs. So we can then rearrange it, make Fs the subject, and we get 640 or 644 newtons. Let's have a look at the next question. An archer fires an arrow at an angle of 1 degree above the horizontal towards a target. The target is 25 meters away from the point of the arrow when it's fired. The arrow hits the target 0.20 seconds after it's fired. The lift force and drag force are negligible during the flight of the arrow. First, you show that the initial vertical component of the velocity of the arrow is approximately 1.7 meters per second. Then the center C of the target is at the same height as the point from which the arrow was fired. The arrow hits the target at point P. Determine the vertical displacement of P relative to C. So pause your video now, then unpause the video when you want to go through your answer. Right, in our first question, what do we know? Well, we know that the vertical value here, so the horizontal, that was looking for the vertical component of the velocity. Okay, well, what are we aware is that we know that the vertical height is going to be 25 meters over 0.260, because we know that it's going to be distance over time. Sorry, the vertical, the horizontal one there. So therefore we can see that it's going to equal to 96 as shown before, which you can then lead it to be 1.678 as you can see before. Now the next one, how do you work out your value through? Well, again, we know that in this case, because the drag force and the lift force are negligible, there's only going to be one force acting on the object. So we can use projectile theory, so we can use the equations of motion and we can see what values that we've got. So we need to work out what S is, but we have been given T, it's 0.60 seconds. We know what A is going to be, because again we know that the only value is going to be gravity there, so as a result we know it's going to be minus 9.81. We know what U is because we've looked at in the previous question, and like I said, we know what T is, so we can say S equals UT plus a half AT squared, pop our numbers in, and we get an answer to be 0.10 or 0.11, so therefore it's between 0.10 meters and 0.11 meters above the center of the target, because you can see in the direction which has been aimed at. Right, let's have a look at our next question. A student places a wooden block on a ramp inclined at 30 degrees to the horizontal as shown in the figure. The block is pulled up by the ramp by a light inextensible string connected over a frictionless pulley to an object of mass 0.4 kilograms. The object is initially held at rest 0.45 meters above the bench. The wooden block has a mass of 0.25 kilograms and is initially at rest. The object is released and accelerates vertically downwards at 2.23 meters per second squared. Explain 2 ways in which the momentum of the object is different from the momentum of the wooden block during this acceleration, then calculate the tension in the string as the object accelerates. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this first question? Well, we know straight away that the magnitude of the momentum, of the block is going to be smaller than the momentum of the object. We can tell this because of how much is actually being moved, okay? And then finally that the two momentums, are going to be in different directions, because you'll notice that one's going in one direction, one's going in another direction. Momentum is a vector, so another difference is they're moving in different directions. Now, how do you calculate the tension in the string? So it's important to note that if you look at the situation, the object is pushing down on the string and producing a force of mass times by acceleration, because F equals ma, it's accelerating downwards, so we can say the force produced is ma. But what about in the other direction? Well, we've got our tension acting in the opposite direction, but also it's important to note that in the same direction as the object falling is going going to be the weight of the object, because it's already acting downwards. So therefore we can say that T is going to be equal to MA plus mg. So when we work that through, we can put our values in and we can see that we get to be tension is equal to 3 newtons. Right, let's have a look at this question again. So we've got the same ideas here, that the object is initially held at rest 0.5 meters above the bench. The wooden block has a mass of 0.25 kilograms as initially at rest. The object is released and accelerates vertically downwards at 2.23 meters per second squared. Show that the object is traveling at approximately 1.4 meters per second before it hits the bench. Calculate the component of the weight of the wooden block that's parallel to the ramp. And then when the object hits the bench, the string becomes slack and the wooden block decelerates and stops. There's a constant frictional force of 1.25 newtons between the wooden block and the ramp. Calculate the distance the wooden block travels parallel to the ramp as it slows down. So pause your video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, in the first question, again, we know that it's accelerating at a constant speed. Okay, also the constant rate, which is 2.23 meters per second. So we can therefore once again use a Suvat equation. So we've got to think we want to work out what v is, which is our final velocity. We know what u is because we know that's initially held at rest. So u is going to equal 0. We've got our acceleration and we've got our displacement when we move in this particular direction in the vertical. So we can say v squared equals u squared plus 2as. We pop our values in and we get an answer for v of 1.42 meters per second. So when we're trying to calculate the component of the weight of the wooden block that's parallel to the ramp, well, straight away when we look at our situation, we can see that when we're given this particular triangle of forces, that the component of the weight parallel to the block is going to be sine angle. So we do the weight sine 30, so we work through to be 1.23 newtons. Then finally calculate the distance the wooden block travels parallel to the ramp as it slows down. Well, it's important to note that we're going to add our frictional force to the component of the weight parallel to the slope, because they're both acting to slow it down. So therefore we do 1.25 newtons plus 1.23 newtons. That's going to be the frictional force, which we're told in the question before, and added onto the parallel component of the weight, because they're both acting to slow it down. So therefore we can say that work done is force times by distance. So therefore we can work out what the work done is, because we can say it's the change of the kinetic energy. So we do a half mv squared to work out our work done. We've got our force because we've just worked it through, so therefore we can work out our distance, because the distance is going to be the work done, which is a half mv squared, divided by our force, which we've just worked out before. So we get our distance to be 0.10 meters. Let's have a look at our next question. A wing screw is tightened using a thumb and a finger. The thumb and the finger each apply a force F as shown in the figure. Explain why the forces shown are acted as a couple. Then the perpendicular X between the lines of action of the force is 3.2 centimeters as shown in the figure. Calculate the force required to reach a couple of 1.2 Newton meters. So pause the video now, then unpause the video when you want to go through your answer. Right, so why is this a couple? Well, we've talked about this before. What is a couple? A couple is when you've got two forces equal in magnitude in the same plane but in opposite directions. Then what's the value of the F going to be? Well, straight away, how do we work out the force? Well, we know that moment is going to be force times by distance. So therefore, our force is going to be the moment divided by the distance between the two objects. Now again, what's our distance? 3.2 centimeters. Convert that into meters, so it's 0.032 to get our answer to be 37.5 newtons. Let's have a look at the next question. Figure 5 shows a child on a sled sliding down a slope. The total mass of the child on the sled is 75 kilograms. She starts on rest at A and descends to a vertical height of 5.5 meters to B. First, you state how to calculate the work done by a force, then show the speed of the sled at B with approximately 10 meters in the absence of friction. So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you work out work done? Well, we know that work done is equal to force times by distance, but that's not the complete equation, because it's actually force times by displacement. So it's force times by the distance travelled by the object in the direction of the force. Now you could also say that this is F times by S times by cos theta, because again S cos theta gives you the direction in the direction motion in the direction of the force. Now Next one, show that the speed of the sledder B would approximately be 10 meters per second in the absence of friction. So again, what do we know? If you look in the situation, we're starting off, we're sliding down a slope, so we're starting with gravitational potential energy, we're turning that into the kinetic energy, so therefore we can say mgh is equal to a half mv squared. You can cancel the m's through because they're equal on both sides, so we can say gh is equal to a half v squared. Therefore, we can pop our numbers in because we know g to be 9.81, we know h to be 5.5 meters, and we know a half v squared on the other side, so we can rearrange it, make v the subject, and we get 10.4 meters per second. Let's have a look at our next question. So figure 5 shows the same child. The actual speed of the sledder B was 5.8 meters per second, and the distance travelled from A to B is 17.2 meters. Calculate, using energy considerations, the average frictional force experienced by the sled. So pause the video now, then unpause the video when you want to go through the answer. Right, so how can you do this? So what you would do is the same as before. You'd work out your potential energy at the start, so by doing mgh. You would then do your kinetic energy, which is a half mv squared, so therefore you would work it through as such. Now then what you want to do is find the difference between the two energy stores. Now we then know that force is equal to work done times by distance travelled, so therefore once you've then done that, we can say that the frictional force is equal to the work done over the distance. Now the work done in this case is the difference between the two energy stores, because it's the work done by friction to transfer the energy from the object to the surroundings. So say friction is equal to work done over distance, and we then get our frictional force. Right, let's have a look at our next question. So figure 4 shows a golf ball hit from a mound of height 12 meters. The initial velocity of the ball is 48 meters per second at 15 degrees to the horizontal. The golf ball takes 3 seconds to reach a position at a vertical height h above the hole. D is the horizontal distance from the point where the ball is hit to the hole. Okay, ignore the effects of air resistance for this question, calculate D. So pause the video now, then unpause the video when you want to go through your answer. Right, so how would you answer this particular question? So you've got to calculate D, which is the horizontal distance. Now it's important to note that in this situation, okay, that the only force acting on the object is going to be weight, which is in the vertical. That's one of the air conditions of a projectile, and we can say that there's no air resistance in the question, so it must be acting as a projectile. So this tells us that the only force acting on the object is in the vertical. So in the horizontal, there's no force acting on the object. So at this point, the object will have inertia in the horizontal. Now when an object has inertia, you can just use a simplified equation that velocity is equal to displacement over time. So at this point we can say, well, what we're going to do, we want to work out the horizontal displacement, so therefore we can say that it's going to be the velocity times by the time. Now the next thing to note is we need to know what the horizontal velocity is. Now you're given the resultant velocity, 48 meters per second, but we need to find the horizontal component of that. Now once again, you've been given the angle to the horizontal, so the quick way you can work out the horizontal is it's the resultant cos of the angle. So we say the horizontal velocity is 48 cos 15, so we get 46.4 meters per second. So therefore the horizontal distance is the horizontal velocity times by the time, because we've got inertia. So therefore it's going to be 46.4 times by 3 is 139 meters. And the last thing you should always do in these questions is check your answer to see if it sounds right. And a golf ball traveling 140 meters sounds like it will be appropriate, so it's most likely to be right. So that brings an end to our revision session today. If we've been successful in this revision session, we should be able to answer A-level physics questions on mechanics, assess our understanding on mechanics, and then understand what topics in mechanics we need to improve on for AQA A-level physics. So thank you very much for watching this revision session on mechanics. Okay, thank you very much and have a lovely day.